Welcome to EDU World Space.
In this video, we'll be finding the surface area obtained by rotating some curve around the x-axis. So we're given a curve and a certain range, and what we want to do first is we obviously want to find some derivatives. So we can do
Here's
so
a clean and professionally
as the
formatted
following.
presentation
I'll do
of
it
the
in blue.
calculation shown in the image.
We have if y is cosine of x over 2,
Application
y
of the work
prime
energy
would be
theorem, WET. From
negative
the
1
work energy
half
theorem, the
times
force
the
F
sine
is given by
of
F equals
x over
frac
2.
tex KE, where KE
And this is due to the
equals
chain
kinetic
rule.
energy, S equals stopping
This
distance.
is due to the chain
Then
rule
given
making our
for
life
object
a little
A,
bit
FA
easier for
equals
us to
frac
deal with.
100,000, 0.10.
So we can put
For
this
object
into
B, FB
our
equals frac
integration formula
225, 1500 equals 0.15
along with the bounds of
text
integration, which
and
is
force ratio
0
frac
into pi.
FA,
So what
FB
happens
equal
is
frac
our
0.10,
surface area will be
0.15
equal
equal
to,
frac 2 null
bringing the
result.
2 pi out,
I'm a
we're
box
going to have
frac
2 pi,
FA, FB.
the integral from
Would you
0
like a
to pi
PDF version of
of
this
y,
explanation?
which is just cosine of x over 2. So it will be like that, cosine of x over 2 times square root of 1 plus. Now, y prime squared squares both of the terms in the product. So this negative here will become a plus 1/4 times the sine squared of x over 2. All of that will be integrated with respect to x. At this point, we can perform a small u substitution. Basically, what that means is that we're going to have we're going to let all of this here, or rather, maybe not that, maybe not all of that. We'll let just the sine term, we'll just let the sine term become u. This will make our calculations just a tiny bit easier. So what that means is that we're going to say let u, let it be equal to 1/2 times the sine of x over 2. When I differentiate that, du will be just 1/4 the cosine of x over 2 dx. Now, obviously, I don't have this 1/4, this additional factor of 1/4 in, so I can multiply it and divide it. So I can divide and multiply by 1/4 at the same time, as follows. This also means that the bounds will change as follows. When x is 0, u will be sine of 0, which is 0. And when x is pi, u will be 1/2 times the sine of pi. And the sine of pi over 2, that's 1, so that will be just 1/2. Simplifying this a little bit, our integral will become 4 times 2 pi will be 8 pi. The integral from 0 to 1/2, and we're going to have 1 plus u squared du. And at this point, we need to make another substitution because we're doing some trig sub now. So we can do the following. We can say that u will be equal to the tangent of t, and then du will be the secant squared. This is because we have an a squared plus u squared situation. And this also means the bounds do have to change once more. So when u is 0, t, the tangent of what angle is 0, that's obviously 0. And when u is 1/2, the tangent of what would be 1/2? Well, just some arbitrary angle. I don't know what that is. There's probably no exact value for it. In any case, we can now substitute all of this again into the formula. So we would have 8 pi, the integral from 0 to the arctangent of 1/2. And we're going to have 1 plus tangent squared t times the secant squared of t dt. So all of this here becomes secant squared within the square root, which is just going to be secant. And multiplying that with the secant squared, it's going to become 8 pi times the integral from 0 to the arctangent of 1/2. We're going to have secant cubed of t dt. And we'll assume that we know how to integrate secant cubed already. It's going to involve some integration by parts. And we'll just give the result right now. So it will be 1/2 times the secant, the tangent, plus the log, using base e, of course, of the absolute value of the secant plus the tangent. And that should be an absolute value bar. But it makes sense. So applying this antiderivative here will give us the following. This 1/2 multiplies with the 8 pi, and we're going to have 4 pi. And this would be the secant of t times the tangent of t plus the natural log, which I'll write as just the log. And since we're clearly positive, I can drop the absolute value bars within the log and just make it parentheses. So I'll have the secant plus the tangent. And this would be evaluated from t equals 0 to t equals the arctangent of 1/2. And plugging all of this in would give us, we would have the secant of the arctangent of 1/2 plus the tangent of the arctangent of 1/2 plus the natural log of the secant of the arctangent of 1/2 plus the tangent of the arctangent of 1/2. And I need one more parentheses here. And one more there. And this will have to subtract, of course, with 4 pi times the secant of 0 plus the tangent of 0 plus the log of the secant of 0 plus the tangent of 0. And one more parentheses there. Okay. Before we do anything, we ought to figure out what the secant of the arctangent of 1/2 is. When we do so, we're going to find we'll find that this is just equal to, you can apply some trig to this. You'll find that this is going to be equal to the square root of 5/2. So plugging all of this in, also realize that the tangent and arctangent will cancel each other out. And also the tangent of 0 is 0. And the secant of 0 is, since secant is 1 over cosine, we have 1 over the cosine of 0, which is just 1. So basically, what happens, we can cancel some terms out. This goes away, this goes away. This second log goes away because the log of 1 is just 0, so this vanishes. So basically what this becomes is we're going to have 4 pi times root 5/2 plus 1/2 plus the log of root 5/2 plus 1/2. And this will be all subtracted from 4 pi. And you can certainly distribute all of this 4 pi and stuff if you want to, which we'll do when we do so. This will be equal to 2 pi root 5 plus 2 pi plus 4 pi log of root 5 over 2 plus 1/2 minus 4 pi. Which would give us the following. We'll have 2 pi root 5 minus 2 pi plus 4 pi log of root 5 over 2 plus 1/2. Oh, and I forgot, this is a multiplication actually. That's a multiply, and that's a multiply. So actually what happens is this entire term vanishes. So this goes away. This is a multiply. This is a multiply. Okay, let's redo that. Let's redo the evaluation part here. When these two multiply, we're going to get this is going to be equal to root 5 over 4. So we can multiply this times that, which will give us the final answer of pi root 5 plus 4 pi log, and we'll combine the fraction here too. So we'll have root 5 plus 1, the whole thing divided by 2, which is the final answer to this question.